In this video, I'll be going over 3 problems from exercise 3, 7.3. Again, in this video, I've skipped over exercises 1 and 2, the fill-in-the-blank columns. Highly recommend that you go back, if you haven't done so already, and complete those fill-in-the-blank problems just to get the rules down. It's essential that you put the work in now so that it's not as difficult, so it doesn't take quite as much time and effort when we really get into the hard part. So I'm just going to go through 3 problems in this video, problems 5, 13, and 20. So starting with number 5, let's take a look at the conclusion that we're asked to derive. We're after not, parentheses, H or not A, which probably is kind of a lot to think about here. It's difficult to just look at the conclusion and know immediately what we need to do. So here's a general strategy for working many of these problems. You might find it to be helpful to, instead of starting with the premises, to start in reverse order. Let's ignore the information that's given to us for now. Just examine the conclusion that we're asked to derive. What can we do with that conclusion? Not an official step to solving the problem, but really just to help clarify our thinking. An obvious move to make with respect to this conclusion, this seems to be a textbook case of De Morgan's. We've got the tilde on the outside, so we can distribute and flip the operator. So nothing more, for nothing more than the purposes of clarification, I'm going to, just in the notes here, not as an official step, but just in the notes to clarify what it is that I'm after, I'm going to do De Morgan's to this conclusion. Distribute to the H, not H, to the not A, which would be not A, and we know via double negation that not A is A. So not H, A, operator starts as a wedge, flip that to a dot. So by doing De Morgan's to the conclusion, I really can see that what I'm truly after is not H and A, which I can now think of as 2 separate objectives. Get the not H, get the A, jam them together via conjunction, and I'll almost be home. And now let's take a look at the information that's given to us. We're after not H and A, and we can see here that half the battle is done for us. We've already got the A, so all we now need to do is get not H. H only appears once and it's not negated. H, the H that's given to us, is the antecedent of a horseshoe statement, and we want the negation of that antecedent. Well, that's way back to section number 1 in this chapter. That's modus tollens. But to do modus tollens, we need the negation, of course, of the consequent. Consequent is not A. So to do modus tollens, we need not A, which we don't have. We just have an A. But it's easy enough to turn that A into not A. 2, double negation. A is logically equivalent to not A. And now we can set up 1 and 3. 1 and 3, modus tollens. And we get out the negation of the consequent. We get not H, which is exactly what we wanted. We want those 2 joined together by a dot. So that's easy enough. 3 and 4 conjunction. 3 and 4 conjunction. Not H and not A. And now we just need to manipulate 5 to make it look exactly like our conclusion. It's pretty close, but not exactly. And so we're just going to undo what we did here in clarifying what it was that we were after. Rather than doing De Morgan's to the conclusion, we're going to do the reverse of that. We're going to do De Morgan's on line number 5. So this time, rather than distributing a tilde, we're going to suck out that tilde. Take a tilde away from the H, take a tilde away from the not A, and bump it to the outside of the parentheses. Take it away from the not H, that just gives us H. Take it away from the not A, we'll still have a tilde left over, we'll have not A. Flip the operator, starts as a dot, ends up as a wedge, and that's the result of doing De Morgan's on line number 5 in the reverse order that we generally do it. But this is common enough. Not as common as distributing, but frequently you will in fact have to suck out that tilde, and there it is in action. That's how it works. So our line number 6 now matches up with the conclusion we're asked to derive, and we're done with 5.